NASA Langland Research Center for Earth observing mission where we study the climate. And by day, I enjoy imaging. How I got started in astronomy, really, and astronomical imaging was way back in 1992 when I saw a picture of the Tackett Nebula on the Astronomy magazine, the cover of Astronomy magazine. And way back then, I decided that someday I really wanted to take a picture just like that. I bought a 35mm film camera and started snapping some photos, but soon thereafter, the camera broke and I had enrolled in college and was poor for the better part of a decade. Which is good timing because really, during that time period, DSLR cameras really became more affordable. And so by the time now I'm gainfully employed and can afford such pursuits, I was able to jump in. I totally missed the film era, which is kind of a shame. Wish we could have gone through it, but
DSLRs are much more fun.
All right, great. Well, the good thing is that I just got into imaging over the past 2 years, we'll say. I've enjoyed astronomy all throughout my life. So the good thing is, by this point, there's so many great options for software for this, between Maxim, DL, Nebulosity, obviously Photoshop's a big powerhouse and sort of thing. I had a great choice to choose from, a great selection. I ended up choosing PixInsight. There are several things about the software that really appeal to my scientific training. They really want you to know the data that you're presented with. So whenever you're creating masks and these sorts of things, you really get to know your data inside and out. And as a part of my day job, that's one thing I appreciate. Whenever we're making maps of something or other, I don't ever like to smooth it and try to make it look pretty, because I like to see the raw, ugly stuff that's there, because that's the science. But there's an aesthetic part of this whole thing that I really appreciate you can't ever get away from. Anyway, so I figured I was going to show this, rather than just kind of listing what tools PixInsight has, instead of put everyone back to sleep. I'm going to go through an image processing example. So with my image of the Tackett Nebula that I took in July, this right here isn't perfect by any means. I wanted to gain more experience in imaging before I actually tried it, but it was before me one night, so I went for it. And so we're going to go through the processing steps. And this is a really good way to learn PixInsight because out on the web, the past year I've been using this, I've seen a ton of new tutorials come out. That's how you learn to image. I started off, I snapped some pictures, then I went through these tutorials trying to learn the process. So here's the workflow we're going to go through here. Notice that we're skipping over pre-processing entirely. But PixInsight has everything you need for your image calibration, your star alignment, stacking, all of that stuff. And in very, very excellent quality as well. But this is where the fun stuff is. So we're going to go through here.
Okay, so just to be straight, so you just start with the raw images, and PixInsight will take it from there, the raw files from.
Exactly. So you start with your subframes. Then they have image calibration modules where you say, here's my dark frames, here's my flats, here's my bias, and then it knows what to do with them appropriately. There's a star alignment module, or a process. So you add in all your subframes and then it registers them to the stars. They also have a comet alignment process. So basically you say, here's my start image, here's my end image, and you have to select the location of the comet, and then it looks in the header file and sees the time between the two and kind of interpolates where the comet should be for stacking. So that's in there as well. And finally, for stacking for image integration, there's a lot of the image integration tool is very, very powerful. There are many ways you can average your images together, depending on how you want to weight them. And so the default way that they do this is by weighting by the noise. So the PixInsight integration process will look at each subframe and come up with an estimate of the noise in there, basically the signal-to-noise ratio, then weight those with the highest signal-to-noise ratio more than those with the lowest. So in the end, you end up getting the maximum SNR. Then, of course, there are other ways to average if you want to, so there's a lot of flexibility. But the defaults right out of the box are very nice. This guys just showed up, welcome. I was saying that for how we're going to work through this, learning PixInsight, how I'm going to demonstrate it today, is by an image processing workflow with this image right here. And okay, so now we have our integrated master light frame, and this is where we start from. And you see we've been reading this whole time, so what we're going to step through starting off with removing gradients, which as we go through each of these, we're going to learn some of the tools that make PixInsight unique, I guess compared to other platforms. First off, I don't have an example of this. So when you first integrate your frames, obviously you're left with a linear master light frame. It's very, very dark. So you need to, you want to know what's going on there. So what you want to do is stretch it in some ways to get some idea of what's there before you move forward. Well, PixInsight has something called the screen transfer function, which is a really powerful tool. So this thing, it actually, it takes your linear image, when you click, so when you click down here, this guy right here, it'll automatically perform a stretch to what you're seeing on the screen so that you can see what's going on, but it doesn't actually stretch the underlying data, which is crucial. You know, your data is still in linear form, but you can see what's kind of a preview of what stretch form will look like. This is really important because some processes really should be done in the linear stage, like color calibration and noise reduction, these sorts of things.
Does PixInsight run at 32 bits or what is?
Very good. So it can make images up to 64-bit resolution. The general workflow most imagers will do, you know, if you're on your DSLR, for instance, you get a 14-bit image depending on your camera. Everybody converts to 32-bit floating point, and you go from there. There are some images where if you're doing a really high dynamic range image, like the Orion Nebula, then you want to go with 64 bits. And then you do your manipulation and save however you'd like. Yeah, very important. So here I'm also going to give you the first show here the histogram transformation tool. This tool is something I'm sure Photoshop has something exactly like it. So right here is the histogram of this image before, then you can move these sliders to adjust the mid tones, dark point, whatever. And this gives you a preview of what your changes will be. Right now, what I'm showing here with this histogram is what the screen transfer function has done to the image, so you can see what's going on. If I didn't have this applied, it would be black and see a few stars. It would be that interesting. So anyhow, by default, the color channels are linked, meaning it's just going to come up with a transformation or a stretch, taking into account all the color channels. What you really want is to unlink them to get a better preview of what's going on. So in this side, it's stretched in such a way that now you can see in the histogram, these red, green, and blue channels are all about the same, meaning this kind of neutralized background, and that's what you want to start with. You get some idea of what's going on. So starting off with gradient removal. Here I most heinously stretched the image just because I want to point out that there's a light gradient going from this side to this side. So where I imaged this, I was just north of Williamsburg, and this is the light, a little bit of light from Williamsburg. So what you use to handle this sort of thing is called the dynamic background extraction tool. The idea is what you're going to do is you're going to put all these sample points on an image. It can automatically put samples on there. So here, you probably want to read about this. See what it says. You pick the number of samples you want per row. Usually you want a small number, like 4 or something like that. And it picks all of these points. Then what it's going to do is it's going to come up with a model background, what the background should look like, and then you can decide if you want to subtract it or divide it out. Yeah. So continuing on, I guess I'll leave the mic. So for each of these sample points, you need to define a radius that it should be. This right here is a preview of each one of these points. The idea is that you only want to include true background in there. You don't want to accidentally put a star in there, because then your model background will have a big hot spot in it. That's not true background. So anyhow, so you click through each of these, and you make sure you don't have any stars in there. You can, with your mouse, move them a little bit as needed. And then, and I should also say with PixInsight, how you apply processes. You see this little arrow down here. Basically, after you set up your parameters you like in here, you grab this little arrow and you drag and drop it on your image, and the process is applied. Another cool thing is there's a workspace for PixInsight, and if you drag and drop this on the workspace, you'll end up making a little process icon that saves all the parameters that are in here. So the neat thing is, as you're going through your processing, you can store all these process icons and save them and share them with your friends or open them up for later. Anyhow, so here's all the points that have been selected. So now here's the background model that PixInsight is created from this. And I should mention the green color you see here, I'm using a CLS CCP light pollution filter. So all my images come out with this greenish blue cast. But dealing with its trivial, as we're going to see here in a minute, in PixInsight. So here's the background model. You can see it's my Williamsburg over here, and nice over here. And what you can do with it, you can either subtract this background or divide it. Or, because light pollution is an additive effect. You know, you're counting the light from your source plus the light from Williamsburg. Whereas vignetting and uneven field illumination is a multiplicative effect, and division does that. So in this case, I just subtracted it out. Let's see, I think here's my cool animation. You can kind of see the light from this side came down. This side here popped up a little bit, but I think overall, it kind of made the field more uniform, the background more uniform.
So Jason, when you have both, when you have a camera, a system that has that, and you have some light pollution as well, you run two?
Yeah, you can run two passes. The convention I use is whatever effect I feel is the strongest, I'll do that first.
Okay.
The problem is once you subtract, then the math doesn't work with the division or vice versa.
Yeah.
So I kind of do whatever is most prominent. But yeah, it's not uncommon, not unheard of for folks to do multiple applications of this to get things.
How does the background extraction work with larger objects like some big sharp objects? Is it a little confused with the nebulosity versus the...
It's tough with a lot of nebulosity. I've taken an image of a Pelican Nebula. You know, there's nebulosity all over my frame, and yeah, you just have to be very, very picky with the points you pick. That is one of the limitations you kind of get towards.
Can you break it up into two layers with just do a star layer and then work on that one by itself before you get to the nebulosity?
Oh, there's ways to do that. Not as there isn't an explicit of a tool as in MaxMPL. That's something that does it automatically. But there are ways to do that, where you can select the stars, and make that into a separate image, and then, as you're saying, the tools are in there to do that. And I think you probably use Pixel Map as the name of the tool we'll show here in a while, and then and a star mask. So.
Yeah, star mask.
But not as explicit as MaxMPL. That's a pretty cool tool they have. Okay, so we've now that we've made the background flat. Next up comes neutralizing the background. And because I still have my screen transfer function on, it already looks pretty well neutralized. I already wish I could zoom in somehow. Anyhow, there's this background neutralization tool. And what you do is, you can hardly see it right there, but you make a little preview. And then in here you say what's the upper limit with which is just the background. So anything higher than this value is going to be a star. And when you hover your cursor over it, this little readout right here, which shows my red, green, and blue values. Because this is floating point, everything's 0 to 1 rather than 0 to 255. So what this says here is I'm choosing an upper limit of 0.007 as my background. And then it'll go through, actually, so I have my filter on. So now the background looks far more neutral than it did before, that sickly green color.
So it's just working on that trigger window, the data that's inside that window?
Right, so it'll look in there, it'll basically make an average of all the red, green, and blue pixels or values for pixels where the value is below that upper limit to avoid stars. Right. And then it'll scale the red, green, and blue channels to make them neutralize, make them all basically the same.
So you kind of just roll around here until you find the spot that you want to do the 3D part.
Exactly. You want somewhere that's the background. So this image was actually a little tricky, so you can see, there's all these, these are just like stars behind a bunch of dust. So if I'd chosen there, I may have gotten kind of reddish bias one way or the other. So it's kind of tricky. Ideally, you want a place with no stars or this background. This is tough because it's a mess. But with the upper limit threshold, you can avoid the stars. So next up is color calibration. So the normal way you'll do color calibration with DSLRs, you'll take a picture of a white card in the sunlight and you say, this is what white looks like. And your software scales everything. The underlying assumption behind that is that human eyes are adapted to light, kind of yellowish light from our sun on white as being white. So it kind of has a little bit of a favor or bias towards our kind of star. PixInsight does this differently. It makes the assumption that it doesn't favoritism to any spectral type of star. And to put it another way, the idea is that if you took every star you could see in the sky and you averaged all their colors together, the average would be white, which is a fairly good, it's a good assumption for stars. For instance, if you want to use the galaxy has a ton of stars, you can use that as a white reference. As long as the galaxy doesn't have too far of a red shift or these sorts of things, it's a good assumption. So in the practical application, what you do in your image is you can see this box I put here. You make another preview, and you say this is a white reference. So I want to use all the stars that are in here as my white reference. And then you still have to tell them where the background is. And so what it'll do is it's going to go through there, it's going to look at the red, green, and blue channels of all these stars, and then it'll say, all right, the mean value, this is the mean RGB value, and I'm going to scale everything so that on average the stars are white. And it works out well. If you can't see too well on here, but if you look at images processed with PixInsight, all of your familiar colors you've seen with objects you've been looking at your whole life are all there. So it works really well. And also it makes the whole, my light pollution filter, my color bias or whatever, it's trivial to fix with this right here. So anyhow, and with that said, also you don't need to worry about white balance on your camera at all, because you do it all right here. And the tool, just here's the background reference. You set an upper limit, just as before. So above this, those are stars. For your, then for the white reference, which is this guy, you say lower limit. So anything below there is background, and that's how you work with it. So let's see here.
Do you find the defaults in most of these are pretty good?
In color calibration, yes. And most things, yes. Sometimes in noise reduction, I think some of the defaults are set expecting really, really good signal to noise ratio, which I haven't had the joy yet of having. So some of that you kind of have to tweak a little bit. For the most part, the defaults were great. Here, there's this thing called structure detection. And what it's doing is white reference. I wanted to use this whole image, and PixInsight would go through here and look for structure. It would say, hey, this doesn't look like any stars to me. It looks like some sort of structure. And it would eliminate that from its color calibration. But if you want to use a galaxy for your white reference, then you want to turn off your structure detection to you're going to use a structure.
I do very similar, especially when you got a lot of nebulosity in there like that. And one of the ways I do it, I just use the whole thing and then find the stars and be very careful on what your lower limit on the stars are. And then your background reference is going to be the lowest point wherever you find it, and just set that, and it will go through the whole image and average it. Even though you've got a lot of nebulosity in there, it works really well. You don't have to do the small
Preview.
You just use the whole image if you've got that kind of image.
Sure, yeah. It gives you, better sampling of stars. You can use your whole image.
Yeah.
Yeah, that's great. So here's an animation before and after. Showing a little bit of the sickly green, a little bluer, a little bit pinkish in the Mission Nebula there. And now we're getting closer to where we should be.
Can you say the white point from a star? Like if I had, I go out with a lot and just look for a G2 star in the field, and then use that as my calibration point for the image. Can PixInsight do that?
Yeah, there's a manual calibration process where basically you'll figure out whatever your scaling factor is based on that star, and you can put it in for each of the channels. So that option is there. Okay, so now that we've white balanced, now it's time to go into the nonlinear stretch. And now we're actually seeing the linear image, which is pretty boring. First I'm going to step through kind of the conventional way the nonlinear stretch happens. Then I'm going to show a way that does a really good job of preserving star colors. So the typical way is to do something like your histogram transformation tool here. And so we're going to increase the midtones by lowering the slider here. Then we'll raise the black point, and then kind of repeat as necessary until you spread out the dynamic range. And I made a little, there's a preview of some stars here. Let's keep an eye on. Okay, so we lower the midtone, we increase the midtones, which is already looking pretty nice.
Yeah, this is all in 32 bits.
point, correct. And then I lower the black point a little bit. That's looking pretty nice. There's our black point lowered. And the background's looking pretty neutral. And the stars look pretty good. You know, I got some red right there, a little bit of blue. That looks pretty nice. So that's the conventional way of doing the stretch process.
How many times would you do that?
How many times do I do this?
Italy.
Yeah, our iterations are necessary until basically you want to make, you know, this is full net velocity, then you want this to be really broad. This is going to be really broad, so you can cover lots of dynamic for the dynamic range.
But typically, would you, you're probably using a different approach, but for me, I would typically do a stretch in levels, maybe eight times, like little bits at a time, versus kind of one just ginormous leap.
Right.
And I find the smaller incremental ones work better.
Then you're absolutely right. You're going to like this this technique right here. There's a function in PixInsight that does the exact same thing called mask stretch. A little different actually. The idea here is that it's going to make a mask that's going to select the highlights. Excuse me, it will mask the highlights. Then it's going to perform a little stretch. Then it'll make a new mask and perform a little stretch. The idea being is, you know, if you do a really aggressive stretch all up front, then some of your stars are immediately going to become blown out white discs. This right here makes it such that doing a mask stretch makes it such that the brighter things don't get brightened as rapidly as the faint things you're really trying to bring out. So this process here, mask stretch, you pick another background, and then you say, here's my target value for the background. You can't quite see it, but I have 0.2 on 1. I always like to go a little higher than what you're going to want in your final image. Anyhow, then you pick a number of iterations. And so when you fire off this process, it's going to go through here. It's going to say, here's my starting background value. Then it's going to figure out how many how small the steps it needs to make in other to get to your target background value and the number of iterations you specify. And you can specify up to, I think, like 1,000 iterations, which works really well when there's, you know, lots of net velocity essentially. So anyhow, so this is at the end of that. And when I was doing this, I tried to end up with the same median background value as the previous way that we showed how to do stretching. So you kind of compare them. Doesn't come out quite as well on this screen, but there isn't quite as much contrast as we had before. This peak gives it away. It's narrower, which means you have less contrast. But if you look here, actually, we're going to zoom in on the stars here, compare them side by side. So this is the the more traditional way, and this is the mask stretch way. And you can see that you preserve a lot more of the star color in here, which is really impressive.
So it actually builds the mask itself, you don't have to create the star mask.
Exactly, yeah. It makes a luminance mask, so it extracts the luminance, it converts it, and then masks. It does it automatically, and it's a pretty quick process. It can go through, depending on how big your image is, 100 iterations in a minute or two or something like that, depending on your computer.
When I'm doing this in levels in Photoshop, okay, I can't export me for PixInsight. I do different channels sometimes. We break it up there. This isn't doing that. This is doing it all at once somehow. It's not. It's like you're not just looking at the red channel, green channel, blue channel, whatever you're looking at. It's doing it all at once.
All at once, right? Exactly. Yeah. So I think that's a fair way to do it because we've neutralized the background and everything. All the rest of the
I have to neutralize the background when I'm starting out and do the levels. I need to do that. So,
Yeah, it's generally good to start.
yeah, you need to do that first.
Yeah, and then that way you can raise it, stretch everything.
Yeah, I'm trying to neutralize the background with the levels. And that's not the way.
Okay, sure.
Okay, gotcha.
So here's our, and look at the histograms here. You also see there's more of these brighter values, essentially what we already know. You're kind of blowing out some stars. And then this histogram peak is narrower here.
Yeah. It looks like more contrast in the past. Well, I can see more net velocity in anything.
Sure. Let's make a quick back. See, that looks pretty good.
Yeah. So you can see the reds.
So what I wanted to do next from here was, now that the contrast isn't quite as great, I want to add some contrast by applying an S curve. Increase the bright stuff, lower the whatever. The only thing is I don't want to increase the stars, which are the bright stuff, too much, we want to keep all the progress we made in keeping the star colors. So that leads us into making a star mask. Because what I want to do is I want to mask the stars and then do my contrast curve and everything else. Let's see here. So it's actually much simpler than I'm going to show here. I want to show a little more involved way to make this star mask. What often happens is that if you have stars embedded in nebulosity, and you try to make a star mask based on a threshold, saying anything brighter than this is a star, sometimes your stars are as bright as your nebulosity, and it's harder to pick out where the stars are. So what I'm going to show here is a way to compress the dynamic range. In other words, make the bright stars really bright and everything else really dark, so the stars kind of pop out. And then we're going to use the star mask process to go in and find all the stars. So the first way to do this, the first step is to extract the luminance. So there's this channel extraction tool. You can see all these different color spaces, RGB, HSV. We're going to use LAB color space, or lab. And what you do is you select what channels you want to extract out of here. I'm going to extract the luminance. I'm not going to worry about the A and B channels, which is the color information. I'm also noting here that there's a shortcut for this process to extract the luminance. Up here, you have your usual toolbar. You click this guy, and the luminance just, there's a separate image of luminance pops out. Okay, so you grab out your luminance. Now we've got our black and white image here. And then what we'll do is to compress the dynamic range, back and forth. Then I'll explain the tool. You can see right now the stars are really bright and everything else is really dark. Now this tool is called HDR multi-scale transform. And so it does exactly kind of as I explained, it compresses the dynamic range. See here, and then you can apply this multiple times. This is a number of iterations here. There are other, we're going to use this tool here in a little bit to bring out some more of the compress the dynamic range of the Trippet nebula itself. So we're going to revisit this here in a few. But this is just one application to really make the stars pop out. So yeah, we got this guy. Then we run our star mask process. You can see the star mask. All right. So the star mask works by you set a noise threshold. You say anything below this value is noise, and then you got some scale here. Basically, what it's going to do is it's going to go through and it's going to look for round things of a particular pixel scale. So if you make the scale really big, it's going to look for big stars. If you make it smaller, it's going to look for small stars. So here I'm comparing scale 8 and scale 5. You see, you get the small stars and the big stars. If you want to, if you just wanted to get the big stars for whatever reason, you can use pixel math to make a star mask for this, a star mask for that. You subtract the smaller stars away from this image and you let the big stars if you wanted that. Then there are other things on here. When it masks over the stars, the smoothness parameter describes kind of how smooth the mask is around each star. If you want to mask not only the star, but kind of a broad region around the star, let's say you have halos or something like that, that's what the structure growth is. If you say for large scale stars, increase the amount of protection. And this is something where it requires some experimentation to get it right. But yeah, pretty powerful, really effective. Then there are other ways, like other kind of masks you can make. If you want contours around your stars, you select that option, so you'll have rings kind of up around your stars. Some people like to do that for their star reduction. So instead of selecting a star and reducing the entire star, you select the periphery of the star and shrink that. Anyhow, so that's the star mask. And then, my animation showing where it's applied. They're kind of similar to other programs. Now where it's red is where it's being protected. So whatever manipulations I do, the red things aren't going to be affected.
Can you go back and tweak that mask with the hand, like you went to just a few things inside it? Is there any way to tweak that with the mouse and put a cursor over and kind of say what's?
Yeah, so with, the star mask itself comes out as a whole other image. So if you want to, you can do anything you want to it. Like if you want to go in there with a clone stamp, remove certain things that you don't want to So here I've applied the star mask. I'm not showing it here, so I'm showing the way it looks pretty. Then here's a curves transformation, much similar to Photoshop. Here's the input values, and here's the output values. And I'm just going to apply an S-curve. Back and forth. Now we're getting closer to where we want to be. The background's getting darker. And the mask is helping protect those stars from losing their color or bloating, things like that. That's a pretty common tool, though. So not too much special here, but a critical tool for the kind of work we do. Okay, so going back to this HDR multi-scale transform. So this thing, how it works is it compresses the dynamic range at different spatial scales. So in here there's a number of layers, which is kind of akin to spatial scale. So whenever that number is really big, it's going to look at large scale structures and compress the dynamic range of those. As it gets smaller, it'll get compress the dynamic range of smaller scale features. You can see my animation here, as you get into the smaller number, you start to see more and more details pop out in there. Whereas at the layer 6, kind of the big poofy lobes or whatever pop out mostly as you get to finer.
You didn't show them how to make the likeness mask.
What's that?
The likeness mask. You're applying the likeness mask.
Ah, yes. So the likeness mask.
How easy it is to do that.
Yeah, that's cool. So the likeness mask on here, whenever you're doing this sort of thing, you don't want to toy with the background at all. So there's noise back there, nothing we're interested in. So traditionally you make a likeness mask to select only the stuff that's bright and not select the stuff that's dark. But here, all you have to do is click that guy right there to likeness and likeness mask. And behind the scenes, it's going to make that likeness mask for you and only apply. So that's cool. It makes it nice. It's behind the curtains. You don't have to mess with it. So for this one, I think I ended up choosing layer 6. I didn't care so much for all the details that came from here. It's like a big poofy tripping. Sometimes what people will do is they'll apply this transform or this process at a layer 6 to get the big scale stuff, then go back to a smaller layer and bring out the smaller scale things. Anyhow, this tool though is definitely a game changer. Okay, now going to contrast enhancement. This function is called local histogram equalization. And the idea is it's going to go through little bits of your image at a time and find where there are differences in brightness and then exaggerate those differences in brightness on small scales. And for here, we're going to zoom in on this guy a little bit. I wish I would have made these things bigger. So there's something called the kernel radius on here. Basically, that's just, it's going to look through, right now it's at 48, so it's going to look at an area of about 48 pixels, I think in diameter, or radius, one of the two. Anyhow, it's going to look at that, and it's going to boogie through the image and enhance contrast at that scale. Whereas if you made it to a larger number, it's going to have a bigger area it's going to look through to try to enhance contrast. Then you can decide, there's a contrast limit, basically how much you want to enhance that contrast. Then there's this amount here, I think I have it set 35%. So that's basically saying that it's going to blend the new version of the image with 35% of the original. Is that right? Well, only 35% of the modification will be applied to the original image. So you kind of blend it in a sense. I'll click back and forth. Yeah, it's kind of subtle in a way, but you can see, I like how the dust really starts to pop out from the background. Oh yeah, I guess I have it going on here too. This is a nice way to just one process to do this sort of thing. And Photoshop has something similar to this, don't they?
Yeah. It's been in the old note that it's increased standards of the positive. Basically, positive and negative. Shift the positive over a little bit, that would find the image with the contrast.
Oh, okay, great. That's cool. So, there's that tool. What else can I say? Also, there's a histogram resolution here. Right now it's going through an 8-bit resolution and enhancing the contrast at that resolution. It can go up to 16-bit. So, to give you more possibilities or more possibilities in contrast enhancement.
Yeah, the nice thing about this versus Photoshop is a lot of the processes in Photoshop don't work at 32 minutes.
Oh, really?
And so, I mean, you basically get HDR curves and levels at 32 minutes. Anything kind of more detailed, you have to work at 32 minutes. So you don't really have much control to do it.
Yeah.
Especially stretching and stuff like that. You can definitely see the difference. 15 minutes is pretty good.
Sure. The PixInsight software development team really put a lot of effort into parallel processing, and they really have this in mind. And that's one of the reasons why Windows XP is no longer compatible. That's with Windows 7 or above, and they recommend 8 gigabytes of RAM or greater. That's what I'm running at to get by.
I run it, I have it on my business machine, and I have to cut down the other sizes and all this. So if I've got more than 4 or 5 images at the same time, it'll run.
Oh, really? Wow.
Run out of memory. It was don't have enough memory.
How much memory are you using?
On the business machine, 2 megs. I mean, 2 gigs.
2 gigs, okay.
But I have Windows 8 and Mac. That's what I really process on. But here I just do it quick and dirty.
Oh, you mean out in the field? Yeah, sure.
But I can't just, none of the pre-processing will work because as soon as you've got the memory, it'll overload.
Wow.
Crash.
I recommend the Mac Pro. That's what I'm using.
I have, well, the iMac works fine.
Yeah, I remember that.
Yeah.
Cool. And yeah, PixInsight is available on Mac and Linux as well. Somebody would like to go your route. Okay, so leading into this, I've been out of town, Colorado for my job for a week, so I haven't got a chance to think about this until the drive here this morning. Okay, so I want to talk more about some mask generation, and I forget why I'm showing this, but it's become apparent to me and all of us here in a few minutes. So there's different ways to make masks. If you want to just select your target image, or the deep sky object you're looking for. So this is the range selection tool. I'm going to select to the range selection. So what you got up here, you set a lower limit for pixel value, an upper limit, and then it'll make a mask based on all pixels that are greater than that limit will be selected, and anything lower will not. You can set these sliders to select the upper and lower bounds. There's this fuzziness parameter, so it makes it less so they're discrete edges. It kind of makes these thresholds kind of fuzzy in a sort of way. And then there's a smoothness parameter. If you didn't do smoothness at all, anything that's above that threshold will immediately be selected. Whereas if you apply the smoothness, it'll kind of smooth the transition between the two. And so here I'm showing when I'm selecting this. I think what I'm leading into here is color saturation and these sorts of things. And of course, you don't want to select the background and saturate the colors. You want the stars and the nebula.
So if you want to create a mask just on one channel, you can basically go back, just create an image with just a single channel and then do mask on that.
Exactly. I did that with this image right here. So what I did with that channel extraction tool we saw at the very beginning, I extracted just the blue channel. So when I was originally processing this, I said, gosh, there's all this blue or luminosity here that I just can't drag out. So I extracted just the blue channel and then applied something similar to this. Just select that and then bring it out.
Yeah, what I tried to do is in Photoshop, I ended up introducing what I would call artificial vignette. Because I don't know how to smooth the edges out in the right way and make it go all the way to the edge in the proper way. And just sort of plunks it around the middle and you just subtleties of this really work.
Yeah, right. Yeah, that's why it's important that, like you're saying, to smooth out the edges and these sorts of things. And that's the neat thing about PixInsight. They give you all the tools such that you really don't ever have to hand paint a mask. And you can kind of let the data speak for itself, essentially.
It also gives you almost unlimited undos. If you find that, oh, I didn't want to do this, you just undo it and change the parameters and redo it until you got it right.
Yeah, that's right.
Again, you go back in the process and take that one and undo it and then have it. You can change it.
So you go back a long way.
Yeah, that's one thing I wish it would do as well. So that for each image, you'll see a history of all the processes you applied. So you can go back at any point and see, I've often wondered if you could, in a manner of speaking, slip a card into the deck and let it just.
So we've been working on it for 2 hours, and we say I should have done that way back an hour ago.
Yeah.
You know, and do that, so I have to do really
I've never tried, but it might be possible because of the history of the process. But you can save these processes and okay, I got it here. Let's call this process X,
okay.
and I drag it down. I've got that process there.
Yeah, it's the
And
process saving part of it.
So you can save the process, and if you didn't like the change, you can always drop it right back to where you.
Exactly. Yeah, that's exactly how I do it as well. If I want to go back to here, I just save all the processes I know are right. Slip my new card into the deck and then just reapply this. Yeah. Okay, so there's the range mask. Now, one thing that's nice to do is to create a nebula only mask. And I'm making this because somewhere down the road we're going to do something with it. But while we're here, so what I'm doing is I'm taking the range mask we just made in the previous step right here, and we're going to subtract the stars away. So the star mask we made earlier. So there's this process called pixel math, where I'm saying here's the range mask, is the name of the range mask, minus star mask. You subtract one from the other, and create a new image. You can see here that for the most part, I'm only selecting the nebula. Looks like I missed some stars here in the middle, so tweaking of my star mask generation. I could have gotten that a little better, but I wasn't too worried about here. But see, for the most part, though, we're blocking out the stars. I often like to do this. I found whenever I'm applying color saturation, that I like to saturate the colors in the nebula separate from the colors of the stars. For some reason, the stars just saturate so quickly and become artificial. So sometimes I like to select them separately and apply color saturation. So yeah, good old pixel math is a powerful tool. I want to show another way to create a nebula-only mask. And this is, so you extract the luminance of the image, as we showed a while back ago. Use your histogram transformation, clip the shadows and highlights, and then subtract the stars with pixel math. This right here, this $T, that means when you apply pixel math to whatever image you're using, that's what this represents. See here. So yeah, so I have my range mask image. When I apply this, it's going to say, all right, range mask minus star mask. So it's kind of a general way you can apply to any image you want. Anyhow, this is a second way to make a nebula only mask. In this one, would you have a question? Oh, sorry. In this one, I use the range mask, nebula only mask. Actually, no, wait, I'm targeting the star, nebula and stars here. Okay, so different ways to saturate color. So here's the color saturation tool. So there's a yellow line across here, and here's all the different colors. And then what this allows you to do is you can grab this guy and drag up and select a particular color to saturate it. Let's see what else comes off the projector. So here I just want to saturate blue. So I'll put it back and forth. So this one bring out the blue. Now this one bring out red. Now in this case, I couldn't saturate the red as much since it's already pretty well saturated. This one looks much better on the monitor here, so forgive me on this. Wasn't sure how to project. So anyhow, this is kind of a novel way to do this because, in DSLR cameras, we often have too much green in the background. So sometimes you want to increase the saturation of all the colors, but green to tame that down.
Can you pick your saturation point off the image, right?
Yes, you can. That's another way to do this here. So in your curves transformation tool, you can select these different channels. And here's the saturation channel. So this represents the saturation. And what you can do is you can, put your arrow right here, or your pointer, and you can click. You'll see where on this line your saturation is. So that's how I chose this curve here, because I wanted to increase the saturation of basically the blues and things that aren't very saturated. But right here, it's actually pretty saturated to begin with. So yeah, there's a way to see where you're already very saturated. And that was the way I chose with this image. Using the color saturation tool, I didn't care for it as much as this, just for the fact that this is already so saturated right here that I want to have more control. So that was how I chose to do it. Does Photoshop have something similar? Yeah. Okay, this is an AMU. All right, so what we've done so far, you can see we've come all the way through removing gradients, neutralizing the background, calibrating the colors, our nonlinear stretch, contrast enhancement, and now we saturate colors. I was planning on saying, if you have any questions at this point, we've had questions along the way. Any questions what we've done so far?
Just come to the next one, I guess. I heard it was, it did come to the next, middle of exams. And you mentioned earlier, when you first started, there were a lot of tools there now. And that's the way I learned most of the stuff I know with Photoshop. Tools, and so forth. And some things I love, like wavy extractor, stuff like that. But I didn't know how good the manual was that comes with PixInsight.
Well, there isn't an actual manual that comes with it. But there are a lot of tutorials on there, on the online. At the very end, I'm going to show there's a website called PixInsight Resources that has a strong affiliation with the PixInsight team. And on there, they have all sorts of tutorials on there, step by step through an image. They'll start off with different galaxies and nebula and whatnot.
If you hover your cursor over things, there's usually an explanation that pops up that says, this is what this does. So while there's not a manual, there's built-in explanation on a lot of these things.
Yeah, it's like what you're saying, if you hover over where it says fuzziness right there, a little pop-up thing will come explaining. And there's also this little, you click one of these guys right here, it'll take you to some internal documentation that isn't thorough yet, but
I use CCD Salt, and started with it for the preliminary process. It's had a 300-page manual that walks you through the whole thing.
nice.
Yeah, and print it out, but when you print it out, you can always go back and I did that last month, and that particular step. And CCD Stack is one of the things too, not that elaborate, but it walks you through, the steps of the whole thing.
Sure, yeah. There's also, for PixInsight, there's some video tutorials out there. Warren Keller and Virginia.
Harry's Esther.
Harry's Astor, that's where that's the place to go.
That's the place to start.
CCD Stack, it's 18 hours long.
No kidding.
He'll be explaining something, and by the time he goes to get through all the details, you forgot what you were talking about.
Oh, wow.
It's really crazy.
I've seen, he's recently started using PixInsight. So there's a forum for PixInsight, and people post their images there. Some of the things that he's showing are so incredible. To show galaxies just, so far away you've never imagined. Yeah. Lucky guy. So at the end, I'll show, have some links, some resources. I should have put Harry's Astor Shed on there. That's the number one for everyone.
Before you see, why do you put it reduce noise down this part of the list instead of?
That's a very good point. There's kind of a story behind that. So, PixInsight team, and most people argue that you really need to do noise reduction in the linear stage of the image. Reasons for that, it depends on the noise reduction process you're using. Some of the processes for PixInsight, I have a table on here somewhere, show. Some of them, the mathematics expects it to be linear or non-linear. The other reason is usually you don't apply your noise reduction to the background. In other words, to areas where the signal to noise ratio is low. And the only time when you can create a mask that is proportional to the signal to noise ratio is in the linear stage. If you want to make your mask apply in proportion to whatever the signal to noise ratio is. Once you've applied your stretch, all bets are off. So those are important to do. The reason why I'm putting it this far in here is kind of historical. I'm still kind of a novice at this. And the first times when I would go through some of my images, I imaged Hampton Roads, it's really noisy, or I was looking at dark skies. So the images were very noisy. So I tried applying my noise reduction at the very beginning of linear stage, and by the time I would stretch and do other things, I realized that I had applied all my noise reduction wrong. Things were terrible. And I didn't have the experience yet to predict, what processes applied that early would have later down the road. So for a while there, I just abandoned it. I said, all right, I'm going to do my noise reduction later so I can have more control on how it's going to look in the final image. I've come a bit further when I worked on this one. And this one, actually, I did pretty good. It was a dark site, pretty good integration time, such that I felt the noise wasn't so bad that I needed to really worry about it. linear stage. And I use the tools made for nonlinear noise reduction. That's in this case, but ideally, you want to use your noise reduction in a linear phase. That's my story.
No, I see.
So I want to just take a step aside. So you've been staring at the same image for a long time, so we'll look at something different while we cover really the big thing about what makes PixInsight different and so powerful is this concept of wavelets. And we're going to look at this image that I took of M101. I think it was last May that I took this image. I was pretty proud of it. For being an honest, it worked out pretty well. Wavelets allows you to decompose an image into structures of specific dimensional scales. So here I'm showing this different wavelet layers. That's how they describe this, wavelet layers. And here's the pixel scale. What this means is, for a wavelet layer of 1 is in reference to structures of pixels that are 1 pixel in size, which is a much of a structure. But as you go up to, say, a wavelet layer 5, now you're talking about structures that are 16 pixels in size. Here I'll just, images speak better than words here. I'll say real fast, for this image, this is midway through the processing of what we just saw. So I've gone through my nonlinear stretch and it's extracted the luminance, so we don't have to deal with the color information. So as we go through here, so at the single pixel scale, you can see there's not much information there. As we start to move along, now you start to see the arms of the galaxy. And then you get really the gross features of it as it gets to structures this size. And the residual is everything that's left over. So the reason why this is so powerful is that you can apply your processes to specific dimension scales. For instance, it doesn't show very well on here, but much of the noise in my image here is in the single pixel and 2 pixel level. You have to get up here and get a really good look. There's a lot of graininess in the background here. But as you get to larger sizes, that graininess kind of goes away. So what that means is you can apply noise reduction, just at the scale where your noise is at, and not affect the other sizes or the other dimensional scales. And there are other tricks you can do too. Here in a little bit, I want to apply some sharpening to the image. And so for this image, I'm not going to show it here, but what I ended up doing for it, I wanted to emphasize the arms of the galaxy. So I picked this wavelet layer, and there's a tool I'll show in a minute, where I applied some sharpening to just this dimensional scale. And that helped the arms kind of pop out from everything else. And there's some other tricks people will do as well. For instance, in this galaxy, there's some nice dust lanes around somewhere. Yeah, these dust lanes. What you can do is you can extract kind of the, I'll say this here. You extract like the green channel, I think it is, and then if you select the wavelet size where these dust lanes exist, where they're most prominent, and then you sharpen those, and then recombine the image. Basically, it sharpens the green, which is kind of what contributes to the brown, and suddenly your dust lanes pop out a little more. So those are more advanced things you can do with this information. So, with that, I was going to go into kind of noise reduction and the table of the different tools you can use for noise reduction.
So just how the wavelets, so the wavelets basically, when you run wavelets, you create, that creates a mask that then you can apply another function to.
Right. Well, so see here, how to say this. This whole wavelet concept is going on under the hood all the time, right? So that HDR multi-scale transform we looked at earlier, which is the dynamic range. Yeah, when you're selecting the levels, that's talking about the wavelet layers. And there is a function, let's see if I can pronounce it right. I never tried to say it out loud. Outros wavelets. I think it's like a French word. What's that? Atros. Atros.
Oh, French.
French. You were from Atros.
I had French in high school.
Let's see if I actually have that here.
Where does a draw be?
Do something.
Yeah. So what this function will allow you to do, this process, is you can select whatever wavelet layer you like, and then if you want to sharpen things at that wavelet layer, you can add a bias to it, which I'm going to show you here. It's kind of the same idea. Here I'm using it for noise reduction. So this is called multi-scale linear transform. It's not yet Altros. Altros?
That's wrong.
Okay.
All.
But it kind of has a similar setup here. Where here you have different wavelet layers. And here's the scale refers to the pixel scale. So wavelet layer 4 refers to pixel, or structures is 8 pixels. And then, where should I put it here? So in this case, I'm going to work on noise reduction at the 1 and 2 and 3rd layers. So here, what I'm going to do is you'll select a layer. So I'm selecting wavelet layer 1. Then I'm applying some noise reduction to it. And you can tweak these parameters. And this will only apply the noise reduction at those spatial scales. There's something else in here that I wish I would have expanded to show here. This is called the detail. What you'll do is you'll select, like for instance, I want to pick out these spiral arms. I'd select the 4th layer, and in this detail, there's a bias you can add to it. So what it'll do under the hood is it's going to decompose your image into all these wavelet layers. It'll add a little bit of bias, a little more emphasis to one layer, and recombine it for you and give you your final image. So there's ways to extract these wavelet layers individually if you want to mess with them, or you can just have, sharpen, reduce noise, or whatever under the hood.
The little circle at the bottom is the preview pane.
Correct.
For this kind of thing, you definitely need that.
Mhm.
See what you're doing there.
Yeah, often what I'll do, you get your main image, and then you can select a preview, then you can adjust to that preview. And because it's a smaller size, last one's like that. And because it's a smaller size, you can apply these processes, which some of them take some time. You can do them rapidly to that little preview. What else do I want to put out here? We're going to see this really a lot here in a little bit, but here's the target. So the target is for this particular case, is the red, green, and blue channels, which is pretty worthless because it's a luminance image. But if you want to, you can target just the luminance itself. The other way you do this, the more popular way is to with LRGB imaging. With a DSLR camera, you'll take your RGB image, you'll extract the luminance, and you'll have your synthetic luminance, and you'll process that over here, make it all nice and sharp. Then you'll do your colors, and you'll saturate, and you'll have noise reduction, then combine. And the tools are all in here to do that. For myself, being a novice with this sort of thing, again, I was having a hard time predicting what's going to happen when I combine my pretty luminance with my pretty RGB. I'd have a mess. So, telling me to go through the learning curves, I would just allow PixInsight to do everything under the hood for me. So all these processes, if I wanted to just do sharpening to the luminance, I could select it here, and then you kind of see gradually your image go the way it went to. Yeah, so I just want to show you noise reduction. Non-linear cases. This SCNR, that's really good for reducing green, kind of similar to Hasta La Vista green or whatever. On these tools.
Actually, you can select the color you want to neutralize. Red, green is the normal screen noise that you get, but you can reduce the
Yes, I've had to do that once before. I too much red in an image. That's a longer story we'll get into if we have time later. But yeah, you can select whatever color you want, it'll help reduce that color. These guys, the one I use the most is this ACDNR. I'll say what that means here in a minute. We're going to mess with it. I'm just pointing out there are many noise reduction tools here. And there's also standard deconvolution as well. I've never had much success with it because your data really needs to be good, and mine tends to be kind of on the noisy side. Okay, so I just want to show here I've applied also in here with this noise reduction. You can apply a linear mask, which is the same idea. It's a luminance mask derived from the data itself. And this is actually really good when your data is in linear form. Because this linear mask is just, it takes your luminance and multiplies it by a certain value, and then there's your mask, and everything's linear. Anyhow, so I was going to show before and after some noise reduction. Here I've really zoomed in somewhere on the galaxy. You can see that the graininess is being smoothed out. The stars are protected pretty nice, as well as the larger scale structures. Okay, so going back to the Trifid Nebula, I'm going to show how I apply the noise reduction with this adaptive contrast-driven noise reduction routine. It works really well. See what we got here. So it applies a low-pass filter while protecting the edges of structures, which is really important. On the PixInsight main page, they have a comparison of noise reduction tools. And they do some hypothetical scenes where they'll have, here's a black box. Well, actually, it'll be a gray box that has kind of a gradient in it. And then they'll apply the different noise reduction techniques and say, all right, how well are you resolving that corner right there? Because sometimes, yeah, it'll get blurred out, or you'll have strange artifacts coming off the side of it. And some tools are better than others at working on those kind of edges. And that becomes relevant if you, somewhere in your image, you have the edge of a galaxy that's real sharp contrast between bright and dark or something. So anyhow, this tool, as it says, does a good job of protecting the edges of structures. Built into it, you can have a lightness mask. So you click on this guy, here's my lightness mask, it's selected. For me, so it's actually going to, so it's protecting, black is where it's protecting, so it's protecting inside the nebula there. Here's your lightness mask parameters. So if you want to, you can adjust the mid-tone, shadows, highlights, just like you would with the histogram transformation. But it does it for you without having to build a separate mask and apply all that. This process you can apply to the lightness or chrominance separately. We'll look at it separately. And in here you can define the number of iterations. The amount again says, all right, just apply 66 or blend 66% of the new image in with the old image. The standard deviation here is just a way to, that's basically the spatial scale noise it's looking for in a sense. Anyhow, let's see if we can go ahead here. Okay, hopefully this comes off well on here. So this is a lightness noise reduction. That came out all right. Here's what I zoom in and did something here. So in this, here we're only selecting the lightness, not messing up the color. They did a pretty good job of reducing the chrominance, or excuse me, reducing the graininess while protecting those stars. The next up, if you're going to do the chrominance noise reduction, with that you really need to protect the colors, your color things a lot more. So you can see I've dropped the midtones and shadows to really protect this as best I could. And then this side of it looks the same. If you want to, you could apply this process and have both lightness and chrominance all at once, reduce their respective noises. I like to do them separately just to keep an eye on things and to make this mask separate for each. Yeah, so before and after, see how it comes out. That doesn't really come out too well here. So it's just reducing the color noise. Yeah, there's another, I wish I would have put an example of this on here, reducing chrominance noise. So in DSLR images, oftentimes in the background, you have to do saturated color some. You'll have very large scale blobs of color that's hard to describe. It kind of looks like a blobby rainbow or something like that. And there's a way that you can reduce that using that trawl. You're going to have to help me out with that. Using that process, what you'll do is you'll select a wavelet layer that's kind of large, because these are large scale blobs of color. And then you'll apply noise reduction, but targeting the chrominance as opposed to the lightness of the image. And then it'll go through there and it'll look for large scale chrominance blobs and reduce the noise on those. There's no way to do it. Okay. All right, so now moving on towards sharpening. So we're using the nebula only mask that we made earlier, one with the range mask minus the stars. The traditional way with sharpening is to use an unsharp mask. And my example here doesn't show really why it's not the optimal thing to use. First off, I'm just going to click before and after. Here's after. You can see things are kind of getting sharp. If you look right here, you'll see some graininess in the background really pop out. Another artifact of unsharp masking is you'll have ringing around stars. So you'll have black rings around stars. So PixInsight has several sharpening tools that either don't have ringing to them, or they can compensate for it in some manner in the process. So multi-scale median transform is a way to for your sharpening without ringing. And it's actually in the mathematics that it doesn't cause ringing, so you don't actually have to do anything to compensate for it. All right, so sharpening, as mask and stuff in the eye. Oh, different colors. Okay, so yeah, similar to multi-scale medium transform, we're going to pick what spatial scale we want. Here's what I wanted to show earlier. Here's this bias that you got in there. So I'm going to pick certain spatial skills, add this little bias, and you got to do this by trial and error. I'm going to target the lightness because there's no need to sharpen the color because color tends to color changes at larger spatial scales than lightness.
Are you applying the same bias on every scale?
Looks like
normally I change the bias on the scale size.
I do it to taste, yeah. So yeah.
I couldn't quite read it and see if you could.
So that one, the top one is 0.05. Yeah.
Oh, okay.
But it's always to taste. I don't by convention, always. Yeah. You kind of have to play with it. Anyhow, so before and then after, it's real subtle. Not pretty well. Kind of a consequence of this, because my star mask, I didn't get all the stars in the middle of this, and it isn't 100% protecting all the stars because I have some smoothness to it. The stars are getting brighter in here, so you'll notice. So we're going to work on reducing those in a moment. Yeah, I tend to be sharpening towards the end as as you get towards the end game. This is what I'm going to put online. That's right, I'm sharpening.
But do you find that when you do the sharpening, that you start getting more noise back again?
If you're not careful, yeah, it's all
I
about.
have that all the time.
Yeah, when that starts to happen, I make sure that my mask is really just selecting what I want it to select. And the nice thing is, because I'm applying a bias at these larger spatial scales, that's kind of at larger scales than my noise is at. So that kind of allows you to be able to sharpen things without bringing back out that grainy noise. But definitely can come out without careful use of these masks and things in here. All right, so this is the final, really getting towards the end game now. The star size reduction. For the most part, if I hadn't done as many tweaks as I had, you don't really need star reduction if you just use the mask stretch tool we used in the beginning, because then the stars don't really get bloated too much. It's not so bad. But ordinarily for aesthetics, we want to make the nebula pop out, and the stars are kind of they're the supporting cast. So there's this tool, great tool, morphological transformation. So here I'm using the star mask from before, but except now I'm targeting the stars as opposed to protecting them. And what it'll do is anywhere that's selected, it can do a variety of things. So erosion is basically, that'll shrink the star essentially. And then there's some ways to do this in Photoshop. Forget the method, it's the same idea when you
It's basically for mask and select stars and run a convex filter over them and shrink it.
exactly, that's the same idea.
The convex filter is a really nice discovery I found for sharpening all kinds of things.
Really?
Yeah, you just take your image, you do a high pass filter on it, and a separate layer, then you do an overlay of that, you fill with it, and it sharpens things up rather nicely without having to do a sharp mask or smart sharp.
Nice. Okay.
I try that first usually, and I usually is happy with just doing that.
Very nice. I'll have to go back to what I've learned about Photoshop processing.
Yeah, good try.
So there's ways you can use erosion to shrink your stars. Dilation is actually, to make your stars bigger. That's actually come in handy before, where I've made a star mask, and then I wanted to protect just a little bit more without having to go through the star mask routine again. I'll go through and I'll make the star mask a little bigger. Then there's kind of a blend of these things. I prefer this morphological selection, and all that is it's a blend between erosion and dilation. So this, we get a selection here. Anything close to 0 means that it's shrinking. Anything close to 1 means it's dilating. So it's kind of a blend between the two. So here I'm mostly shrinking the stars. Amount, I always keep it kind of low, and I do lots of several iterations to kind of slowly knob the star and make it smaller. Let's see, before and after. Yeah. So I just kind of want to tone them down a little bit. And that's towards the end. Okay, so there's our summary, all that we've done. What's once again, skipping over pre-processing, but if we have time we want to talk about it, we can. And I was going to put up the resources. So the PixInsight forum is really where you're going to learn a lot, and a lot of tutorials in there. And the software development team is real responsive. They do. How much the price?
How the price is it?
I think it was like US dollars or somewhere around $290.
Is it a single machine license or?
No.
No, you can put it on any machine you want.
I bought one, I have it on PC and Mac.
Yeah.
I have it on 4 computers, so.
Oh, wow.
Well, I can put it on my work.
All yours, right?
2 laptops working and I'm at.
Nice.
Yeah, just make sure you back up your license, stuff, there's a backup, it creates a file that's like you said, you move it around, you do a different directory or something, you won't find it, so you got to have the license.
Question?
We get a copy of your workflow?
Pardon me?
We get a copy of your workflow?
Sure thing. I'm going to find some way, maybe through the through Chaos, to post this somewhere to share with everyone.
Yeah, that'd be great.
One thing I wanted to say, so on my Astromin webpage, for every image that I put up there, I put my workflow of every single one. Just to kind of
If you want to, you can post it on our website to Richmond Club.
Okay, great.
Both of them would be great if you don't mind.
Sure thing. Yeah, we'll coordinate that after weekend.
Jason, I think a lot of the forums also show workflows. Very similar workflows, how to do it in detail.
Yeah, exactly. That's really how I learned everything I know. Is just started off with an image and then went through several workflows. The forum is pretty incredible how quickly the software team is. They recently, in the past 6 months, released a drizzle integration tool, which is huge, because you know, Deep Stacker has had this for ages. So they recently released that, and then in about a month or so, somebody said, "Hey, there's this thing working where I do a meridian flip, some of the things don't work." And in that very same day, the principal software developer said, recognizes, "Oh yeah, the bug. That's a confirmed bug." That afternoon, we fixed the bug and issued a release, issued a revision to everyone. So just to have that kind of support, it's pretty incredible from the people who make the product.
Yeah, the one thing I like about PixInsight that I did find is the Richard solution stuff in there, where if you have some oddball things in there that you want to fix, you can go in and do that in a very neat way. It's kind of fun to play with, actually.
That's a deconvolution.
Yeah, the deconvolution is pretty good. If you have something slightly oddball, it'll be a circle.
I see you tell about with like,
Yeah, if you have something at the edges, you want to keep the edges, but you've got some oddball going off the edges, you can go in and say, okay, my oddball looks like this in the tool, and then you tell it to apply that to the image, and it does things down to more circular things.
nice. Yeah, that's helpful when you get a little bit of alignment error.
Yeah, exactly.
Do they do their fixes with just a purpose, or do they send out deliveries?
Yeah, new little bug fixes come out, every few weeks, every couple of months.
You get an email that says such and such is available.
Or if you open up your software,
Is it the whole release, is it the whole order again, or is it just?
oh, just the update. Just the update, that little tool.
They have major releases of which you have no, the updates, it pops out and says, oh, there's updates available, you want to download.
Yeah, sometimes they're just little bug fixes, but about 6 months ago or something, this drizzle integration tool came out. This was a minor revision release. There's several. There's a drizzle integration, all these new tools and scripts and whatever put in there.
So is there scripting for PixInsight?
There is. You can write your own scripts, and I think it's based on Java or something like that.
Yeah, they have their own Java engine.
Yeah, so you can write your own scripts, and people will post them to the forum, and often what will happen if it's a good script, then they'll ask if you want to include it in the next software release.
Okay, no, actually.
So actually,
they're a pool of scripts that you can run.
Exactly. It's like that masked stretch that we saw there. That originally was a script that somebody had written. Then the PixInsight team gave it a process.
All the calibration is a pre-processing script that you can go in and select it. It comes out and says, put your bias, put your yards, select them all, run, come back, go get a cup of coffee, come back. But sometimes I don't use it for registration or SAC. I only use it for calibration.
The updates, both fixes are included in the original price.
Yeah.
I'd like to say I had to, pay for
No kidding. What?
The Sky Days have been really generous with their time. As long as you can afford it.
Oh, it's a subscription kind of deal?
Yeah.
That's the other thing that turned me towards turned me away from Photoshop. When I was trying to pick out what software to use, I really hadn't never used Photoshop much either. But the fact that it was a paid subscription and this is a hobby, whereas this, $290, and I have all my tools, everything's already built in. That's why
Mine was a little cheaper because I bought it several years ago in euros. I think it's 170 euros.
Okay, so 250.
Something like that when I bought it, but it depends on if the euro. If the euro goes down, that's when you buy it.
Yeah.
You have a demo
Yeah, they do it. A 30-day demo. You have a question?
Do you use it for camera for your examples? DSLR?
These were DSLR Canon 1000D,
Okay.
full spectrum modified. Tonight I'm going to be using a 550D, and that's a sad story. So my 1000D one night I was imaging like the Crescent Nebula. This is 2 months ago. And I had to do a meridian flip, and it was dark, and I was tired. And I leaned down like this to look through the eyepiece, and the cable that plugs into it yanked it right out of there, and the camera had stopped communicating with the computer. That's went to bed.
Yeah.
And then I ordered a 550D and sent it off to Gary Hollis, and I'm back in business. But yeah, so DSLR for right now, and then
What's nice on the cable, you can get, you go on your camera, go something, just be cable, keeps popping out.
no kidding.
Yeah.
Okay, we'll talk more later. You can point out to that.
And I assume this works just for LCD.
Yes, this works very well for CCD. Yeah. So they have ways to deal with the DSLR, color filtered array, and all that, and CCD. I get the impression that most of the tools, well, everything works for both, but I think they often have CCD imagers in mind more, because those are the more advanced imagers, which is what they can really target to use CCDs.
Hey, look, I use that for Photoshop. This seems to be written for the kind of stuff we do in Photoshop more than that.
Yeah. Yeah, that's a good point.
There's a good actions for Photoshop, though, and want to do some of this stuff.
Like Neil Carmoni's.
Yeah, the drawing tools and any actions and those things are all pretty good for fancy effects.
Well, they say with PixInsight, I got this because I don't have any interest in daytime photography, but they do say that you can use this for daytime photography. It says your usual crop tools in there. There's no painting or anything like that. That's not really built for that. But you can do daylight images with it as well.
Actually, I use it for everything like
Really?
process. But the Canon tools are much easier to use.
Sure. I don't need to go through all this for that. Yeah.
Well, there's some video for the two big PDF files. That's right.
Oh, you can? That's news to me. Wow.
I think you can.
Oh, great.
We got into those PixInsight convictions, like you get emails, like, hey, we got a PixInsight user's conviction, and then
Yeah, they're usually somewhere where
somewhere in Europe, but that might be a nice trip to do. But I just wondered if anybody had gone to one and felt like it was worth the effort or an expense, or if you got really a lot out of it, or it was just such like
if you were if you were a professional astronomer using it, it's probably But
they talk it at like a 10,000 foot level.
And then one thing I had just a couple of months ago that said, we're just going to have this at a small house and we're going to sit at a dining room table with like 5 or 6 people. That looked like a pretty good opportunity.
Well, they had a weekend thing at this international students up in Cambridge. The guy, I think one of the authors came over from Europe to do like a 3-day thing. It was like $250, which is not bad. You have to stay in Cambridge for a period of time. It was $1,000.
Yeah.
there's in color calibration. I don't know if you pay any attention to the linear fit function, where you can do the color calibration for that, and you separate the colors, fit it to green, or if you got HA or anything else RGB, you can calibrate your colors that way. Recombine them in your calibration.
You're right on top of each other. Yeah.
So that, I've used that before. Harry's actually
use that as well with, I went through one of Harry's Astroship tutorials with a picture of a comet that I took earlier, where I want to have the comet and the star stationary. So you do that by, when you want a comet only image, so of course I registered with the comet, and then I set my threshold to throw away stars essentially, really, really high. And when I did that, that means that the image where the stars were registered versus where the comet was registered, the backgrounds were a different value, they were different brightnesses because of different data rejection or whatever. So I use linear fit to make the backgrounds match the two and then blend the two.
Yeah, the thing, I've been using it for 2.5, 3 years, and I still, every time I look at it, I learn something new.
Yeah.
The only processing difference from your flow to mine is I usually do the neutralization before I do the background extraction. I found that I can find it. Sure. Once I've neutralized the background, then I can go through.
Yeah.
Yeah. So, I 1 and 2 are flop.
Sure. Yeah.
I neutralize the background first before.
Yeah, ordinarily the way I do it, in the dynamic background extraction, there's by default, it will neutralize your background for you all in that one step. I kind of separated it out here so I can explicitly talk about it. That's usually how I do it.
And also, you have to adjust. It depends on where you are and how noisy your image are. So there's that scale that starts out at 0.5, and I usually end up having a 0.75, 0.9 because it's looking at differences, the standard deviation of difference in the gradient.
We're talking about the dynamic background extraction?
Yeah.
Oh, let's look at that then, yeah. I want to know what you know. And somewhere in here-ish.
It's the model parameters.
Okay, so I have it closed there.
You have it closed down, but in there, the model parameters, especially when you use generate, a lot of times you get nothing because the gradient's a little severe or the noise is too high. So if you have to jack up your model parameters a bit so that you check.
I think I know the parameter you're talking about. Yeah, so it's really small and it's going to reject a whole bunch of stuff in your sampling point.
The default is 0.5, and I find that going to 0.75, I've even gone as high, depending on the sky pollution, it's 0.95, because one side would be really, bright, really bright, and the other side would be reasonably dark.
Right.
And so it just doesn't produce it. At 0.5, it doesn't produce any sounds.
You can manually set your samples to background.
Oh, yeah, you can manually set it all of them if you want, but.
Usually I'll start with this and then kind of.
And then you take it away and put it in.
Yeah.
I have a lot of success saturating actually the linear data, saturating before I stretch.
Really? The color saturation?
Yeah. Using a luminance mask, which I've stretched, but not stretched all the way. It's still, still relatively dark. But it's saturating and the linear, the way the data are in the linear state really helped.
Make the colors pop out more
Yes,
later
exactly.
on.
And then I'll touch up after.
Okay.
A little bit of touch up after. It's
If you're doing LRGB, you do want to do that first.
yeah. But even with the
Just
DSLR, even with DSLR, so
Yeah, DSLRs are, I don't know about which would be better. LRGBs,
Because they'd be kind of washed out.
yeah, they get washed
Yeah.
out.
Okay.
Sure.
You see it on the registration with,
What's that? Okay. I guess we start to visit some more. We'll call us the end of the official thing. But, I'll stick around.
Very informative.
I just think taking the usage much sharper with the
see where that can help bring out the edges of things.
It's a much subtler way